Can y'all see it? You see it? All right, you got it? Yeah. All right. So today, which is the 14th, and first let me say that it's good to actually be in person. I know we had a bunch of hiccups. Um, but today we're doing aspirin synthesis. All right. And for those of you who are logged in, can you hear me? Okay.
Yes.
Yes, I can hear you.
All right.
Yes.
So we're doing aspirin, excuse me, synthesis, and it's a very simple experiment. Couple of techniques involved. We're going to learn about using a steam valve. Somebody in here. We're going to learn about that. We're going to learn about vacuum filtration. We're going to learn about different measurements, and the most important thing, how to set up a synthesis. All right. So with this aspirin synthesis, if you downloaded the data sheet, the reaction scheme is up top, right? We're going to take, and you should have filled out, if you haven't already, you'll have time today, but you should have filled out the reagent table. And we're going to actually look this up even before we start. So we're going to take salicylic acid, which looks like this. And for those of you taking part one, right, again, you can never get away from these functional groups, right? That's the carboxylic acid, an alcohol, and an aromatic. And we're going to take that and we're going to do what the type of reaction with the aspirin synthesis is. It's called an acellation. I mean, right, this is called an acellation reaction, and I'm going to show you why. All right, so we're going to take salicylic acid and we're going to react that with acetic anhydride, which looks like this. All right, this is a type of ester. You can see that the ester functional group right there. And so with that acetic anhydride, this group that's attached here is going to end up on your alcohol. All right, so that group that I have highlighted in red from the anhydride, it's called an acyl group. So that's why we call it an acellation. All right, we're going to take that group and attach it. The overall reaction, the acellation reaction, is a type of esterification or synthesis of an ester. That's what we're doing. All right. So aspirin itself is a type of ester, right? It's got multiple functional groups. One of them is the carboxylic acid. The other is going to be an ester. So when we put these two together, hopefully you had a chance to watch the aspirin video. So I'm not going to go through the mechanism here because I really want to just get cracking on the experiment. So when you put these two together, what you end up with is aspirin, which is here. The carboxylic acid doesn't get touched. And then you have O. Let me do something real quick, change the color on that. Right. So this is aspirin or acetyl. Go ahead and mute salicylic acid. So acetylsalicylic acid. And then one of the leftover products is acetic acid. So it's this HO. CH3. So that's left over from here. It's this piece that's, or not that, it's this actually this piece. All right. So we're doing the reaction in the presence of sulfuric acid. Fix my arrow. So sulfuric acid, H2SO4, deadly stuff, but we're only using a catalytic amount. And we're heating this up. So we're going to use a water bath. Right. So while we're doing this reaction, what you're going to find out is that as you heat those reagents, the solution of salicylic acid is a solid, acetic anhydride is a liquid. When you heat them together, and we're doing it neat with no solvent, when you heat those two together, eventually, when the esterification happens, that solution is going to go clear. So all the solid is going to dissolve and be absorbed by in solution. And then once you get that, once it goes clear, then you're going to continue to heat for an additional 5 minutes. After that, you're going to take it off, let it cool to room temperature, put it on an ice bath, and then filter it. So I'm going to put the steps down here. So the steps for the synthesis, first step is to weigh out salicylic acid. Should have brought a stylus. No, I'm good. Add acetic anhydride. I'm just going to abbreviate that. And sulfuric acid. Sulfuric acid is your catalyst. We're only going to add a few drops. I think the procedure calls for 6 to 8 drops. All right, and that's just going to facilitate this, the acyl part of that acetic anhydride is going to activate it. Right, if you watch the video, you saw the activation part where you just do a proton transfer with this oxygen right here. So that's going to get protonated by sulfuric acid. It's going to make the carbonyl more reactive. And then the oxygen from the salicylic acid is going to attack it. All right, so we're going to add acetic anhydride and sulfuric acid, and then we're going to heat. Sorry. Right, heat until the solution is clear. And then when it goes clear, I'm going to heat for an additional 5 minutes. Right, and that's it. And after that, we're going to filter it. So one of the things about this experiment is that sometimes one of the pitfalls that happens every semester is sometimes you won't have your water bath won't be hot enough. If your aspirin happens to go solid, then all you have to do is just heat it for a longer period of time. But if you heat it and then it cools down some, it's going to go solid. So for those of us who are here, we're going to make sure that we keep it immersed in the water bath at all times and keep moving it. Keep swirling it to make sure that that it doesn't go solid on it. That's the only misstep that happens with this part. Then when the next time we come back, we're going to do the purification, but it has to sit for a week to dry before we can do that. So we're going to get started, and I'm going to take these notes and email them to myself real quick so I can post them to Blackboard. And then, okay, never mind. All right, you should be able to see the balance from here. So I'm gonna weigh your stuff out for you. So grab so this is the way we're gonna set this up. Let me show you that. So we're gonna take, everybody has a 400 ml beaker. So I want you to take that beaker and put about 100 milliliters of tap water into it. All right, so we have let me turn the camera back around. This is off. All right, so we got a 400 ml beaker and we're gonna put tap water. we're going to use this to make what we call a water bath. All right, so that's how we're going to heat this up. In organic, you do not use open flames. I know you use it in CHEM, but that's because you didn't work with stuff that was volatile. In organic, everything is volatile. Everything is giving off vapors. And if you light a Bunsen burner in here with this acetic anhydride, it's poof, be gone. Everybody, all of us, gonna be somewhere, East Alabama or wherever. Ohio, it's gonna take about 3 hours, so I don't know how many of us are gonna survive. But you always want to use a hot plate, and you never use an open flame, right, in organic. So we're going to put some tap water into here so we can start our water bath. So go ahead and different. So we got a water bath that we're going to set up. Turn the camera back around. So you can see on the hot plate, excuse me, we have a water bath here. We're going to turn the hot plate on and start that water to boiling. So go ahead and turn your hot plates on. Put the water bath on there, because while the water is heating up, you can be weighing out your stuff. One thing about lab is you want to be as efficient as possible. Everybody always asks, "We really got to stay at 5 o'clock?" Well, you stay as long as you have to stay, but you can make the time a lot shorter if you actually work efficiently. All right. So I'm gonna grab my goggles because now it's about to get real. What heat do you have? I would put it probably on about between, what you got? Let me see which one you're working with. Put it on about 5. Yeah. You just want the water to be, now this is, you want this water to be boiling. If we're doing a recrystallization, which we're going to do not next week, we're going to take next week a gap and have another lab the following week, because I got an overlapping lab on Wednesday. So we can't meet again next week. But if you were doing a recrystallization, you would not want your stuff boiling. But this, you want boiling. All right. So we're going to heat that up. And while that's heating up, we're going to come over here to the balance. All right. So we have the balance. We have salicylic acid, which is right here. Let me get the camera. All right. I need everybody that's zooming, everybody that's here. Look on the handout. You see that block that says molecular weight for salicylic acid? Put this number in there. 138.12 grams per mole. That way, when you weigh out the 138.12, did y'all hear that on Zoom? Salicylic acid molecular weight is 138.12. If you don't have the handout, don't worry about it. Just write the numbers down. And actually, I'm gonna put it on the board. And while the experiment is going, then you'll be able to copy it. So 138.12. All right, acetic anhydride. You need the density as well as the molecular weight because it's a liquid, and you're gonna have to convert from milliliters into grams. So the molecular weight here is 100.06, and the density is 1.06 grams per milliliter. Molecular weight 100.06 grams per mole. Density 1.06 grams per milliliter. All right, put that in the box. The reason why this box is so important, this reagent table is so important, is because when it's time for you to calculate the percent yield and the theoretical yield, if you don't know the moles, if you don't know the limiting reagent, then you're not going to be able to do that calculation. All right, so we do all this stuff. That's what I'm saying about being efficient. You do all the preliminary stuff up front, get it out of the way, and then you just run the experiment and get the results. So we'll take a piece of wax paper.
The old school way?
Say again?
I said the old school way.
Old school, yeah. Trap house way. Don't tell nobody I told you that. Don't tell nobody. Don't ask me how I know it. I'm just do it. So we got a piece of wax paper on the balance. Normally we'll take a weigh boat, but weigh boats are very expensive. You can get a whole roll of wax paper for $5, and I've had this for like 4 years. So, and we're gonna weigh out 6.9 grams. Put that in the required, says required amount in that box. 6.9 grams. And then for acetic anhydride, we're gonna do 7 milliliters. Where did I put my syringe? All right. So you're gonna weigh this out with a scoopula. And of course, if you took chemistry already, you should know you always got to zero this thing out. So we're gonna zero it out, and then we're gonna weigh out 6.9 grams. All right, we had 3.62, so I can kind of gauge and see how much I need. And just for the record, I'm the GOAT when it comes to weighing out stuff. I really am. Weighing and pouring. No, that's not up for discussion.
Might have to challenge you to that.
Come on with it then. What you waiting on? Come on, Cletus. All right. Get on up in there. Come on. Cooperate. It's hot though. The next step is going to be to add, so you got 2 more steps. We're going to add acetic anhydride directly to that Erlenmeyer flask. And then after we do that, we're going to add some sulfuric acid as a catalyst. It says 6 to 8 drops. And what that sulfuric acid does, y'all can't see this, but what the sulfuric acid does, if you can see that on the board, the H2SO4, that's going to actually protonate this oxygen right here. It's going to do a proton transfer with this oxygen and activate it so that this hydroxyl group, as a nucleophile, can attack that carbonyl. So that's the purpose of the sulfuric acid. So we're going to add first, we're going to add the acetic anhydride, and it's 7 milliliters. So those of you who are watching, I'm going to focus on this right here. You can see the flask on the table. And I got a little syringe I'm going to use, and I'm going to just come around to each group or each other. Man, now your hot plate is not lazy. It's aggressive.
Put the work over here.
Yeah, I feel you. I feel you. GOAT status.
Yes, sir. Those recognizes GOAT.
You heard it. So 3. So we're going to add this directly. In the handout, it says to add the acid on an ice bath, but we're working on a smaller scale, so we're not going to have to cool it down. All right, so don't worry about that part in the procedure. Everything is good. Take my word for it. All right, and this reaction is done under what we call neat conditions. That means no solvent, right? It's neat. All right, so that's 7 mils of acetic anhydride. Hopefully y'all can see me. And then I'm going to add in 6 drops of sulfuric acid. All right, so that's six drops of sulfuric acid.
Dr. Russell, where is the handout for this? What
It's
is
on
it?
Blackboard, course documents, weekly experiments. It's the first handout in there.
Okay.
All right, so now once we've added the acetic anhydride and the sulfuric acid, we're going to take this flask. I'm going to have to bump you up a little bit because you want it to stay hot. If it cools off too much, it won't dissolve. The reaction won't go. So we're going to take this and we're going to add it right to the water bath. Sit it down in there. And what we're going to do is we're going to heat it until it goes clear. So let me show you. Let me zoom in. Right, you can see right now it's not clear. Right, it's cloudy. But the longer you heat it, the more reaction is going to go. So we're going to leave it in the water bath, and all you got to do is swirl it. Every now and then, I want you to swirl it to keep it mixed. All right? And I'm going to keep the camera right there. And I'm coming around to the other groups. Let me come over here to the work. That's not a change in brain. That's not going to be consumed. We're going to regenerate that sulfuric acid at the end every time. That his is going all the way clear, right? So you can see all the acetic anhydride and salicylic acid has reacted, right? So it's all the way clear. So now once it goes clear, you just let it keep heating it for another 5 minutes and it's good. All right. What about you back here? You good? Is it going in? Yep. Hold that up. Yep. So you can see his is gone clear. That means the reaction is almost complete. And then same here. You want to turn that, get that last little piece reacting. Come on now. So let me show y'all that part too. Like if it calls for cold water, what you can do is, boom, you can just stick the water, take the base off the graduated cylinder and just stick it down into into a cooler or an ice bath or whatever you want to do. Omari added water to his and then immediately turned cloudy. And so what the water does, see, aspirin is not soluble in water. And so what we're going to do is force the aspirin out of the solution by adding water and then cooling it down on an ice bath. That's the colder the solution gets, the more insoluble the aspirin becomes. So we added 40 mils of water. And so now what we're going to do is we're going to put that on an ice bath and watch it crystallize. It's weird. So for the setup for your filtration, you need a Buchner funnel. It's this little ceramic funnel right here. I'm going to send y'all a video because I got a video with the glassware on it. So you can at least have that. But you need a Buchner funnel. You need a filter flask, which is this. And you can see the little nipple on the side. That's the part that connects to the aspirator on the sink. And that's how you get your pressure, right? Because the sink is going to pull vacuum once you seal it up. But you can't seal it up without either a stopper or a filter adapter, which is what this thing is right here. So this goes here into your funnel, and then you just sit it down in here, right? And if it's too big, if the filter flask is too big, you can flip it over like that and sit it on top. And both ways, you're going to get vacuum. Either way, it doesn't matter. All right, I think these filter flasks, the mouth on them is too narrow for these, but we're going to make it work. Always make it work. All right, so I'm going to turn this around. Right here, you can see on the sink, you see the aspirator, the little nipple coming off the side. So we're going to set this up. And got that. Yeah. Oh, that's tight. For now, because it don't want to do right. So we're going to take a piece of a coffee filter, just a regular coffee filter, 100, 200 for $1 at Walmart. And we'll sit that down into here. Now I know it's kind of big, but that makes it better at the end, right? Because then you can just lift it out. And the way if you want to seat it, if it doesn't want to act right, you can always just drop a little bit of water onto the filter to seat it down into the funnel. So let's get those set up for everybody, and we're gonna roll. So we need filters and filter paper for everybody. All right. Anybody got any questions so far? Y'all good?
We good.
We're good. Thank you.
All right. Oh, really? That's how you gonna do? Man.
You try to steal it.
No, you got one already. You just need a adapter. All right. So I think we got everybody. No, you don't want it to come through. The water's going that way. Two is gonna pull back. So you don't want any water in your place. All right. So I think we're ready. Thank you. So let's you can take the aspirin out of the ice bath and swirl it around a little bit to get it off the sides and all that stuff. And let me see it before you filter. So this is what you want right here. You want your aspirin to be a white crystalline solid, right? And so since we have that, we're gonna let me see. Yeah. Sometimes if the aspirin is real chunky, you can break it up. Right? That's a physical change. That's not a chemical change. So it doesn't matter if you break it or crush it. It doesn't matter, right? So we're gonna take this and kind of move it around some. All right. So I got a glass rod, and I'm just gonna chop that up a little bit. So when I get ready to filter it, it'll all come out. There you go. So when you filter it, you're gonna turn on the water supply. Excuse me. And while that water is going, you're just gonna pour that on. And I think don't you have to rinse it twice? 15 or 10 mils. Is it 15 mils twice? 20 mils twice. All right. So go ahead and pour it.
For like all of it?
Just don't dump it, but just pour it on. And you'll see in the flash, you're gonna see the water start to come through to the bottom. Right? Because if you're pulling back on it. So get all the solid on there that you can, and anything you can't get, just turn it over and tap it. Oh, yeah. I'm coming back. Here you go, Larry. I'm gonna just give you 40, so you don't have to keep coming back. Yeah, you're gonna rinse it with this. No tap water. That's what this is for. You're gonna add 20 swirls, pour it, and then add the other 20 swirls and pour it.
It's okay like this.
Yeah, ideally, you want to get everything. Don't leave nothing.
I don't know if I could use the water.
Oh yeah, the water is not the problem. One more little piece in there, but uh-oh. I ain't saying nothing if you don't say nothing. All right. Everybody on Zoom, you straight? Do y'all feel like you're getting a lab experience?
Yeah.
Somewhat?
Yes, sir.
Good. So when we come back again, next week, we got to stagger it. I got a general chemistry lab on Wednesday that overlaps with my Wednesday. So I don't want to have Tuesday come and not Wednesday. So next week we'll stagger it. And then when we come back, it'll be the second set of groups, but we'll be doing the purification part. Need some more?
Dr. Russell, I have a question.
So you're saying your Wednesday people for Wednesday will stagger the week after the next?
No. The Wednesday lab tomorrow is going to meet. But when we come back, so next week, we're going to stagger it. So next week, we won't have an on-ground lab because I got to do my Wednesday GCHEM lab. But I don't want to meet the Tuesday people and then have Wednesday not come because I'm doing the other lab. So I'm just going to stagger both labs for next week. But tomorrow, the Wednesday people will be here, and they're going to be making aspirin too.
Okay.
While that's filtering, this is my favorite part of lab. Clean up. So
You don't put anything on there? Do you want us to calculate this one?
you can look it up, but since it's catalytic and it's just such a small amount and it doesn't react, all you're going to need is the molecular weight and the density. Yes. Who?